Hey guys, welcome back to my channel. In this video, we'll be doing questions 4, 5 and 6 from class 12 HSC's chapter 2, application of derivatives, exercise 2.4. So in the previous video, we did questions 1, 2 and 3 which was released yesterday, which I dropped yesterday. So in that one, we saw the concepts of increasing and decreasing functions, how you find out in which interval the function is increasing and in which interval the function is decreasing. So in this one, we are going to be using those very concepts. In all three of the questions, both the concepts are going to be used. You have to tell where the values of x, where the function is increasing and decreasing. So like we already know, to find increasing and decreasing functions, you need to find the differential of the function, which I've done already in this case over here. So let's go on to the next part, which is to find where it's increasing and decreasing. So now if you see in this one, the 3 is a constant. So to find out if it's increasing or decreasing, we don't need the 3. This part over here, let's factorize it, right? 4 has what factors? 48. 48 has the factors 12 and 4. So we'll write this as, one second, we'll write this as x square minus 12x plus 4x minus 48, right? So it becomes x into x minus 12 plus 4 into x minus 12. So it becomes x minus 12 and x plus 4. Now, like I told you, we'll be making our number line, right? So let's make our number line right here. Okay, so one number will be minus 4 and one number will be 12. So let this be minus 4, let this be 12. We all know how it went, right? On the rightmost part, it's going to be up and our wave goes something like this. In the areas where it's up, it's increasing. In the areas it's down, it's decreasing, right? That's it, done. Over here it's strictly increasing, over here it's strictly decreasing. Alright, same over here. So what you will do is, under the first part, you'll be writing the answer as minus infinite to minus 4 union 12 to infinite, and in the second part your answer will be minus 4 to 12, and then we are done. Let's move on to question number 5. Question number 5 is following the same steps as question number 4, right? Again, we have already differentiated the function given to us over here. 6 is a constant, no need to use that. Let's factorize let's factorize our 5. So what are the factors of 24? First up, 24 can be written as 8 3s are 24. There you found it, right? So x square minus 8x plus 3x minus 24. So you have x into x minus 8 plus 3 into x minus 8. So it becomes x minus 8 into x plus 3. We all know how we can make the number line in this case, right? First of all, we have our number line here. Now what are the factors? One is negative 3 and one is 8. So a negative 3 here and 8 here, right? Our wave goes like this, increasing in these parts and decreasing in this part. So the first one, which is increasing, is going to be minus infinite comma minus 3 union 8 comma infinite. The second part is going to be minus 3 comma 8. Very well. Moving on to question number 6, which is the last question. So we'll be trying to complete this video in less than 10 minutes, right? Already done with 2, last question is left. But this one is a bit difficult to differentiate. Why? Because it's a fractional value, right? It's not really difficult because if you know UV rule and UIB rule, U by V rule, it's going to be extremely easy, right? So I've used U by V rule over here. Okay, so the rule I used here is U by V rule of differentiation. If you have not read about this rule, don't forget to check out my shorts and videos. I have made a short regarding this and a video solving questions using U by V rule as well. So here's your function. What you will do, first of all, V into differential of U minus U into differential of V upon V square. Simplifying that, and this is what you get. Right. So how will we factorize this now, right? You don't have to factorize this because this is always positive, right? X square is positive, so 1 plus x square is always positive, and the square of that is always positive. So this part is not going to give you much of a hassle, right? The denominator is forever positive. You have to worry about the numerator now. How will we sort this out? If you see carefully, 1 minus x square, right? Doesn't this seem familiar? You can factorize it as 1 plus x into 1 minus x. So x is going to be minus 1 and 1. Let's whip out our very cool number line here. So you have a minus 1 and a positive 1, right? So it's going up like this. Again, now we know where it's increasing and decreasing, right? So it's increasing in this part and decreasing in this part. Really easy. Now there are some cases wherein sometimes it's like x square, instead of 1 minus x square, it could have been 1 plus x the whole square. What would you do in that case? So so this is only an if situation, okay? If you get 1 plus x the whole square somehow, right? What will happen is, suppose this is your number line and this is your factor minus 1. Since there is a square, the wave bounces off at this point. That means it's strictly increasing everywhere, right? So it's nowhere down, it's increasing everywhere. That means your entire function is strictly increasing. There is no part where it decreases. So with this, we are done with the video. We are done with the 3 questions. And tell me the answer for question number 6 in the comments down below. That's it for the video. Don't forget to like, share, subscribe, comment down below if you have any queries or suggestions, or if you have any particular concepts you want me to explain, or any particular questions you want me to explain. And thanks for watching.